Our topic today is relative density. You are welcome to today's class. In our last class, we treated density, and today we'll be looking at relative density. To find the density of a substance, either liquid or solid, the mass and the volume need to be measured accurately. The mass can be measured more accurately, but for the volume, there might be a source of error. Scientists have found a way of eliminating this error by using the idea of relative density. The density of pure water is taken as the standard density, and the density of other substances may be considered relative to that of water. The relative density of a substance is defined by the ratio density of the substance to density of water, or mass of substance to mass of equal volume of water, or weight of substance to weight of equal volume of water, or upthrust in liquid to upthrust in water. Relative density is also known as specific gravity. The word gravity implies weight. The term relative density is recommended rather than specific gravity in this present time. Determination of the relative density of a liquid. To determine the relative density of a liquid, a density bottle is required. This bottle has a glass stopper with a fine hole through it so that when it is filled and the stopper is inserted, the excess liquid rises through the hole and runs down the outside. A chemical balance or an electronic balance can be used in all the weighing in this experiment. The bottle is clean, dried and weighed when empty. And then when full of the given liquid, it is weighed again. Having cleaned the bottle, it is filled with water and weighed for the third time. The results are set out as below. Mass of empty bottle M1, mass of bottle plus liquid M2, mass of bottle plus water M3, mass of liquid will now be M2 minus M1. Mass of water will now be M3 minus M1. The relative density of the liquid is calculated as follows. Relative density of liquid M2 minus M1 divided by M3 minus M1. You need to note the following. 1. Relative density is a ratio. And another, the relative density is a scalar quantity. Relative density of a liquid can also be determined using Archimedes' principle. There are two precautions that are necessary for this experiment. 1. The outside of the bottle must be wiped dry before weighing. And 2. To prevent expansion of the liquid, the bottle should not be held in warm hands, because if there is expansion of liquid, some of this liquid will spill out. Now we want to look at the relative density of a solid, how to determine the relative density of a solid. To determine the relative density of a solid, this solid needs to be in powder form or granular form, such as sand or lead sheet. The relative density bottle is clean, dried and weighed when empty. Secondly, it is reweighed when it is 1/3 full of sand or lead sheet. Thirdly, the bottle containing the sand or lead sheet is then filled up with water and reweighed. Finally, which is the fourth one, the bottle is cleaned and filled with water and weighed. And after getting all these parameters, you will now be able to calculate the relative density of sand or lead sheet using the formula relative density of sand or lead sheet is equal to mass of sand divided by mass of equal volume of water. I will leave that arithmetic for you to do. Now we are going to take one example. And the example goes thus. A flask with a volume of 500 centimeter cube has a mass of 60.0 gram when empty and 495.0 gram when full of turpentine. What is the density of turpentine in kilogram per meter cube. We are given these parameters: volume of flax 500 centimeter cube, mass of flax 60.0 gram, and mass of flax when full of turpentine to be 495 grams. Now, to get mass of only turpentine, we are going to subtract the mass of the empty flax from it. So it's going to be 495 minus 60, which will give us 435. We are looking for the density of turpentine. We will apply the formula: density is equal to mass divided by volume. By the time we substitute, we'll get 435 divided by 500, and our final answer will be 0.87 gram in centimeter cube. We are asked to find our answer in kilogram per meter cube. So to convert from grams per centimeter cube, we are going to multiply by 1000, and then we arrive at the answer 870 kilogram per meter cube. I hope you enjoyed the lesson. If you have any question, you can drop it at the comment section below. See you in our next class. Bye.